In this video, we are looking at percents of increase and percents of decrease. So percent of change is equal to the amount of change over the original amount, right? So if something changes, we're looking at how much it changes by over the original amount. So change obviously could be an increase or it could be a decrease. So if the original amount increases, that would be a percent of increase, which can be found with this equation here. Percent of increase equals the new amount minus the original amount over the original amount. So, for example, if you grew 6 inches in a year, right? Maybe your original height was 5 feet, and the following year you were 5 feet 6 inches. So we would take the new amount, 5 feet 6 inches, and subtract the original amount, 5 feet, and that would give us our amount of change, 6 inches. That's how much you grew. So we would take the 6 inches and divide by the original amount, 5 feet, and that would tell us our percent of increase, what percentage of your height you grew by. Okay, and if the original amount decreases, we call that a percent of decrease, and it's exactly the same thing. So to find the percent of decrease, you take your original amount and subtract the new amount, right? So that's the other direction. But again, we're just finding that difference. And then you're dividing by that original amount. So that's a whole lot of words. Let's look at some numerical examples. So finding a percent of increase. So looking at this table, right? On Saturday, you spent 2 hours online. And on Sunday, you spent 4.5 hours online. So that percent of increase is going to be equal to the new amount, 4.5, minus the original amount, 2, divided by 2. So 4.5 minus 2 is 2.5. So now we have 2.5 divided by 2, and that will be our percent of increase. So if we take 2.5 and divide by 2, we get 1.25. But we want to write this as a percent, not a decimal, so we move our decimal twice. So this is 125%. So our percent of increase here is 125%. In other words, you spent 125% more time online. Or another way of saying that is your time online increased by 125% from Saturday to Sunday. Okay, another example, something growing from 10 inches to 25 inches. So again, that would be the new height, 25, minus the original height, 10, divided by 10. And 25 minus 10 is 15. So we would do 15 divided by 10, which is going to be 1.5. And so again, we write that as a percent, which is 150%. So it grew by a factor of 150%. It's 150% taller than it was before. Okay, now looking at a percent of decrease. So one example here, we have you hit 28 home runs in 2020 and 20 home runs in 2021. So our percent of decrease, right, we've gone from 28 to 20, so that's 28 minus 20 divided by our original number of 28. So that would be 8 over 28. So 8 divided by 28. 28 goes into 8 0 times. 28 goes into 80 twice. That would be 56. 28 goes into 240 8 times. That's 224. And 28 goes into 160. let's see, probably about 6 times, maybe 5 times. Yeah, it's probably 5 times. Let's see. 8 times 5 is 40. 5 times 2 is 10 plus 4. It's 120. Oops, sorry, 140. Can't fit another one in there. We'll do one more here, because this one's going to keep going. So 28 goes into 200. That's going to be 7 times. 7 times 8 is 56. 7 times 2 is 14, plus 5 is 19. So we can see here, we get 0.2857, which we can round to 0.286. So turning that into a percent, we get about a 28.6% decrease. So let's look at another example. You scored 18 goals in 2017 and 10 goals in 2018. So 2017 you scored 18 goals and then 10 goals in 2018. So subtracting those to get the change, and then that's 18 goals originally. So that would be 8 divided by 18. So 18 goes into 8, 0 times. 18 goes into 80. Well, 18 times 4 is 72. We can see that's going to be a repeating decimal, 0.4 repeating. So if we turn that into a percent, 44.4 repeating percent. So it was a 44.4 repeating percent decrease in goals scored from 2017 to 2018. Okay, and then we've got something called percent error. And a percent error is simply the amount of error over the actual amount. So let's look at an example problem here. You fill bags with about 16 ounces of dog treats. So your target amount, your goal is 16 ounces, but it's not going to be perfect every time. The acceptable percent error is 5%. So as long as you're within 5% of 16 ounces, then it's acceptable. So you fill bag A with 15 ounces and bag B with 16.5 ounces. And we want to know if each of these bags are acceptable within that 5% error. So we want to start with, right, we want to see the amount of error over the actual amount. So our amount of error would be our target amount, right, the difference between our target amount and the actual amount. So if our goal was 16 ounces and we actually got 15 ounces, right, 16 minus 15 is 1. So the amount of error, we're 1 ounce off of our target, and we want that over the actual desired amount. So 1 over 16 ounces. So we find that percent here. 16 goes into 1, 0 times. 16 goes into 10, 0 times. 16 goes into 100, 6 times. That's 96. 16 goes into 40 twice, so that's 32. And 16 goes into 80 5 times. So if we turn that into a percent, we get 6.25%. So bag A had a percent error of 6.25%. This is greater than the acceptable error of 5%, so bag A is not acceptable. Now let's look at bag B. So the target was 16 ounces. We filled it with 16.5 ounces. So 16.5 minus 16, that's an error of 0.5 ounces. Again, divided by our target amount of 16. We've got 0.5 divided by 16. 16 goes into 50 3 times. 16 goes into 20 once. 16 goes into 40 twice. And 16 goes into 80 5 times. Turning that into percent, we get 3.125%, which is less than 5%. So bag B is acceptable.